Hi guys, welcome back to my channel. In this video, we will see some functions and their graphs. In my previous video, we have seen introduction to functions. So if you haven't watched that, there is a link in the description box below. You can check that out. So now let's see first a function, that is identity function. Here identity, which means name itself says same or identical. So function is defined from R to R, that is real numbers to real number. So function of the form f of x is equal to x is a identity function. So whatever value you give for x, you will get the same value. Let's take x is equal to 0. So f of 0 is equal to 0. What value you put here, you will get the same value. So such functions is called as identity function. So function of the form f of x is equal to x is an identity function. Now let's take x is equal to 1. So f of 1 is equal to 1. Let's take x is equal to 2. So f of 2 is equal to 2. Now let's see x is equal to minus 1. So f of minus 1 is equal to minus 1. Similarly, x is equal to minus 2. So f of minus 2 will give you minus 2. What value you put here, you will get the same value. So this function can be represented in two forms, that is by rule, that is f of x is equal to x, and by graph. So let's see how to represent that by graph. So we have x, x dash, y and y dash. So this is center 0, 1, 2, 3, 4, 5, 6 and so on, minus 1, minus 2, minus 3, minus 4, minus 5 and so on. So we have 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5. Here what is y? Y is nothing but f of x. We are taking the value of f of x is equal to y. Now let's see for what different values of x, what is y. So here f of x is nothing but y. Right? So when x is 0, what is y? Y is 0. So that means this point. When x is 1, what is y? Y is 1. So when x is 1, y is 1. That means this point. Similarly, when x is 2, what is y? This is y, right? So y is 2. So when x is 2, y is also 2. And when x is minus 1, your y is minus 1. So minus 1 and minus 1, this point. So when x is minus 2 and your y is f of minus 2, that is minus 2. So my x is minus 2, your y is minus 2, that means this point. So when you join these points, you will get a straight line. So the graph of identity function is a straight line. Now let's see what is domain. We know domain is nothing but it's a set of values of x at which function is defined. So here for all the values of x, function is defined. So x is a real number, right? So therefore domain is R. Now let's see what is range. So range here is a set of values of f of x. So the values of f of x are real numbers. So therefore range is also a real number. So I hope this is clear. Now let's move on to second function, that is constant function. But before that, pause the video and note this down. Now let's move on to second function, that is constant function, where function is defined from R to R. So the function of the form f of x is equal to c, where c is a constant. So function of the form f of x is equal to c is a constant function. So here whatever value you give for x will give you a constant. Say for example x is equal to 0. So f of 0 is equal to c. So now x is equal to 1. So f of 1 will also give you c, that is a constant. Similarly, if you take x is equal to minus 1, So f of minus 1 is equal to constant. So such functions are called as a constant function. Let's see how to represent that by graph. X, we have x dash, y and y dash. So this is center 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. Here we have minus 1, minus 2, minus 3, minus 4. So 1, 2, 3, 4, 5. So y is equal to f of x. So now let's take a constant c, any distance on the y axis, which is a constant. Let this be the distance, which is a constant. So now for x is equal to 0, f of 0 is a constant. So for 0, this is a point. Now x is equal to 1, f of 1 is a constant. So for 1, this is a constant, here this point. So now for x is equal to minus 1, f of minus 1 is equal to constant. So x is minus 1 and the constant c, here this point, right? Similarly, if you see for different values, let's say s is equal to 2, f of 2 is equal to constant. So for 2, it's a constant. So that means this point. Similarly, if you take x is equal to minus 2, so f of minus 2 is equal to a constant. So x is minus 2 and y, this is equal to y, right? So y is equal to constant. So this point. So when you join all these points, will give you a straight line like this. So the graph of constant function is a horizontal straight line like this. Now what is domain? Domain is nothing but the set of all the values of x where function is defined. So here x values, these are all the real numbers. So for all these values the function is defined. So therefore domain is R. Now what is range? We know range is nothing but it's a set of values of f of x. So the values of f of x are c. So therefore in range we have only c. There is only one element in the set, right? That is c. So I hope this is clear. Now let's move on to the third function, that is polynomial function. But before that, pause the video and note this down. Now let's see the third function, that is polynomial function, where function is defined from R to R and function of the form f of x is equal to a0 plus a1x plus a2x square plus a3x cube plus and so on up till anxn, where n is a non-negative integer and a0, a1, a2 and so on till an belongs to R. So the function of the form a0 plus a1x plus a2x square and so on up till anxn, where n is a non-negative integer and a0, a1, a2 up till an belongs to R. So such expressions are called as polynomial function. So here we have various expressions. So for different expressions we have different graphs. Now let's see the graph for the expression f of x is equal to x square. So this is a polynomial function. Now let's see the graph for this expression. So we have x, x dash, y and y dash. So this is the center 1, 2, 3, 4, 5, 1, minus 1, minus 2, minus 3, minus 4. So minus 1, minus 2, minus 3, minus 4. Here 1, 2, 3, 4 and 5. Now let's put the value for x. X is equal to 0. So when f of x, f of 0 is 0 square, that is nothing but 0. So f of x is equal to 0. Here y is nothing but f of x, right? So this is y. So now when x is equal to 1, f of 1 is equal to 1 square, that is 1. when x is equal to 2, f of 2 is equal to 2 square, that is 4. So when x is equal to 3, f of 3 is equal to 3 3s are 9. When x is equal to minus 1, f of minus 1 is equal to plus 1, that is minus 1 the whole square. Minus of minus is plus, so 1. Now let's see for x is equal to minus 2. So f of minus 2 is equal to minus of minus is plus, 2 square is 4. So let's plot these points on the graph. So for x is equal to 0, your y is 0. So this point. When x is 1, so y is 1. So this point. When x is 2, your y is 4. So this point. When x is 3, y is 9. So 3 is here. So on the y axis if you have 9, so it will come somewhere there. So now when x is minus 1, f of minus 1 is 1. So minus 1 and 1. So this point. Now when x is minus 2, your f of minus 2 is 4. So minus 2 and 4. So here. Now let's join these points. So this graph is called as parabola. So now what is domain in this? So domain is nothing but all the values of x where the function is defined. So for all the values of x, here x is r, that is a real number. Now what is range? Range is nothing but set of values of f of x, that means these values. If you see here, all are positive. When you give negative value also you will get a positive. So we have r positive, that is positive real numbers. Now let's see one more expression of this polynomial function, that is f of x is equal to x cube. Let's see what is the graph of x cube. Now let's see the expression f of x is equal to x cube, which is a polynomial function. Let's put the values for x. When x is equal to 0, f of 0 is equal to 0. When x is equal to 1, f of 1 is equal to 1 cube 1. When x is equal to 2, f of 2 is equal to 2 cube, that is 8. When x is equal to minus 1, f of minus 1 is equal to minus 1 the whole cube. So minus 1 into minus 1 into minus 1. So minus of minus is plus, plus into minus is minus. So 1 1's a 1, 1 1's a 1. So minus 1. When x is equal to minus 2, f of minus 2 the whole cube. So minus 2 into minus 2 into minus 2. So minus of minus is plus, plus into minus is minus. So 2 to the 4, 4 to the 8. So minus 8. So now let's see the graph for this expression. So we have 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So here 1, 2, 3, 4, 5, 6, 7, 8, y, and we have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So when x is equal to 0, f of 0, which is nothing but y, which is equal to 0. So 0, 0 is this point. When x is equal to 1, f of 1 is 1. So 1 and 1. So this point. When x is equal to 2, f of 2 is 8. So when x is 2 and y is 8. So this point. When x is equal to minus 1, f of minus 1 is minus 1. So minus 1 comma minus 1. So this point. When x is equal to minus 2, f of minus 2 is minus 8. So minus 2 and minus 2, minus 8 here somewhere. So let's join all these points. So you'll get a graph like this. Now let's see what is domain. We know domain is nothing but the set of values of x at which the function is defined. So for all the values of x, the function is defined. So therefore r. Now what is range? We know range is nothing but the set of values of f of x is called as range. So the values of f of x Here if you see, all the values are real number, right? We don't write positive here because we have negative as well, right? So only R. So I hope this is clear. Now let's move on to the fourth function, that is rational function. Now let's see the fourth function, that is rational function. So function is defined from real numbers to real number. So function of the form f of x is equal to g of x by h of x. So the function of the form g of x by h of x, where h of x is not equal to 0, and these two expressions, that is g of x and h of x, are the algebraic expressions. Here also for different functions we have different graphs. So let's take one expression, that is f of x is equal to 1 by x. So this is a rational function where x not equal to 0. Now let's see the graph for this expression. 0, 1, 2, 3, 4, 5, and here we have -1, -2, -3, -4, -5. So here we have -1, -2, -3, -4. This is your x dash, this is x, and here we have 1, 2, 3, 4, 5, and so on. So this is y and this is y dash. Now let's see for different values of x. Let's take x is equal to 0.5. So your f of 0.5, what is 1 by 0.5? You'll get 2, right? Similarly, let's see where for x is equal to 1. So f of 1 is 1 by 1 is 1. Now let's take x is equal to 1.5. So f of 1.5 is equal to 1 by 1.5. That will give you 0.67. Similarly, let's take for x is equal to 2. F of 2 is 0.5. Let's plot these points. So when x is equal to 0.5, your f of x, that is your y is 2. So when x is 0.5, that is somewhere here, right? So y is 2. So that will be this point. Similarly, when x is 1, f of 1 is 1. So when x is 1, f of 1 is 1. When x is 1.5, your y is 0.67. So when x is 1.5, this y is 0.67. So somewhere here, right? So when x is 2, your y value is 0.5. When x is 2, y is 0.5. It's like this, somewhere here. So one thing you can notice, whenever the value of x is increasing, the y values are decreasing, that is tending to 0. Agreed? So when x values is increasing, your y value is tending to 0, but it will not be equal to 0. Right? So when you join all these points, you will get a graph like this, very close to x-axis. Similarly for the negative values, now if you take x is equal to -0.5, your y value will be -2. So for x is equal to -0.5, let's take x is equal to -0.5. So that is this point. So y is -2. So it will come around here. So when you take x is equal to -1, your y value will be -1. So when you take x is equal to -1, y value will be -1. So this point. When x is equal to -1.5, your y value will be -0.67. So when x is equal to -1.5, that is here somewhere, y value will be -0.67. Somewhere here. Similarly, when x is -2, your y value will be -0.5. So -2, -0.5. So that will be somewhere here. If you take more points, you will get a graph like this. here also it is tending to 0 but not equal to 0. So this type of graph is called as hyperbola. Now let's see what is domain. So domain is nothing but for all the values of x where the function is defined. We know at x is equal to 0, function is not defined, right? So real number minus 0, that will give you the domain. Agreed? Similarly, what is range? All the set of values of f of x. So at 0 function is not defined, so we don't have that value, right? So we have to exclude that 0. So r minus 0. So this is your range. So I hope this is clear. Now let's move to fifth function, that is modulus function. Now let's see what is modulus function. Here the function is defined from r to r. So the function of the form f of x is equal to mod x. This is called as mod. So here this modulus makes any quantity positive. If there is a negative quantity also, by writing modulus, that will be positive. So if it is positive, then it will be positive itself. When x is negative, this modulus will make it positive. Now let's break this function. So what I mean is f of x is equal to, when x is greater than or equal to 0, when x is greater than or equal to 0, the function remains x, which means x is a positive value. So it gives a positive value itself. Now when x is negative, that means it's less than 0, which means x is negative value. So when x is negative, f of x will give you minus x. You have to take f of x as minus x. Let me give an example. Let's take x is equal to 1. So when x is 1 means it's greater than 0, right? So this condition, when x is 1 greater than 0, you will take f of x is equal to x. So f of 1 is x. Here x is equal to 1. Now if I take x is equal to minus 2, what is f of minus 2? Here x is less than 0. So this condition, so we have to take minus x, right? Which is equal to minus, x here is minus 2, so minus 2. So minus of minus is plus 2. Let me give another example. Let's take x is equal to minus 3. Minus 3 is less than 0. So this condition, right? So your f of minus 3 is minus x. So minus of x is minus 3. So minus of minus is plus 3. So this modulus, when you get modulus, it will make negative to positive. Let's see the graph for this. So let me do here. So here we have x. So x dash, y and y dash. So 0, 1, 2, 3, 4 and so on. Here we have minus 1, minus 2, minus 3 and minus 4 and so on. Minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4. Alright. So when x is 0, okay, let me write x is equal to 0 at 0. So f of 0. When it is equal to 0 means you will have x itself. So x is 0. So at 0, your y value is 0. So this point, this is your f of x, right? When x is 1, your y is also 1. So when x is 1, y is 1, this point. When x is minus 2, y is plus 2. So when x is minus 2, y is plus 2. So this point. Let me take, when x is minus 1, so your y will be plus 1. So when x is minus 1, y will be plus 1. Similarly, when I take x is equal to 2, your y will be plus 2 itself. When it is positive, you will get positive. So when x is 2, y is 2. So this point. So when you join all these points, your graph would look like V. So here what is domain? So domain is nothing but the set of values of x at which the function is defined. So x is for all the values of x, right? So that means real number. Now what is range? Range here, there is no chance of getting negative, right? Everywhere you will get positive. And also this graph lies in the positive region, right? So therefore we have R positive. Range is the value of f of x where the function is defined. So I hope this is clear. Now let's move on to the sixth function, that is Sigm function. So now let's see what is Sigm function. Here function is defined from R to R. So the function of the form f of x is equal to mod x by x, where x is not equal to 0, and when x is equal to 0, the function is 0. Now let's break this mod. So we have f of x is equal to mod x, x greater than or equal to 0. Your mod x will give you x, right? By x we have, for x less than 0, your mod x will give you minus x. So this x we have, right? And also we have x is equal to 0, function will give you 0. So we already have a condition for x is equal to 0 is 0. So we will take this equal to sign. Alright. So now we have for x greater than 0 this function, for x less than 0 we have this function, and for x is equal to 0 we have this function. X is equal to, so for x is equal to 0 it is 0. So here if you see this and this will go, so you will get 1. So this will be minus 1 and this is 0, right? Let's see the graph for this. So this is x dash, here x, so this is y and this is y dash. So 1, 2, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. We have minus 1, minus 2, minus 3, minus 4, minus 5. For x is equal to 0, your function f of x is 0. So this is your f of x, right? So for x is equal to 0, function f of x is 0. So this point. So now for x greater than 0, for all the positive values, you will get 1. So for all the positive values, you will get 1. So y is 1, right? So like this is a constant. So for all the negative values, for x less than 0, your function f of x will give you minus 1. So for all the negative values, therefore all the values of x which is less than 0, so these values, your y value is minus 1. That means like this. So I repeat, for x is equal to 0, function f of x is 0. So this point. For x greater than 0, for all the values of x which is greater than 0, the function will give you 1. So for all the positive values of x will give you 1. So this line, that's a constant, y is equal to 1. Now for all the negative values, for x less than 0, so for all the negative values, your y value will be minus 1. So this line. Now what is the domain in this? So domain is nothing but real numbers, right? For all the values of r. So any value you take in x, you will get y as 1, and any value of x which is negative, that will give you minus 1. So domain is r. Now what is range? Range is nothing but value of f of x. Here f of x values are 1, minus 1 and 0. Only these three values. So range will include 0, minus 1 and 1. So I hope this is clear. Now let's see the seventh function, that is greatest integer function, which is also called as GIF function, GIF. Now let's see this function, that is greatest integer function, that is also called as GIF, where function is defined from R to R. So the function of the form f of x is equal to x within the square bracket. Now what is this? So this will give you a value greatest integer less than or equal to x. So greatest integer less than or equal to x. Let me give an example. Let's take f of 1. Where x is equal to 1, right? So what is the value of this? Here it says it should be a greatest integer less than or equal to x. First let's see what is the integer less than or equal to x. So the integer should be less than or equal to x. X here is 1. What all are the integers which is less than or equal to 1? So we have equal to 1. So 1 is included. 0 less than. So -1, -2, -3 and so on. And we want greatest integer. Among this, which is greatest? This one is greatest, right? So the value of this is 1. Now let me give another example. When x is equal to 1.5. So f of 1.5 is equal to 1.5. So first let's write integer less than or equal to x is 1.5. What all are the integers which is less than 1.5? So 1 less than or equal to 1.5. So 1.5 is not an integer, right? Integers will not come in points. So it should be less than, only integers that is less than 1.5. So we have 1, 0, -1, -2, -3 and so on. Among this, which is greatest? So 1 is the greatest, right? So the value of 1.15 is also 1. Now let's take x is equal to -1.5. So for x -1.5, -1.5. So first let's take integer less than or equal to -1.5. So you have to take an integer which is less than or equal to -1.5. So -1.5 is not included. So -1, we have -2, -3, -4 and so on, right? So among this, which is greatest? So -1 is greatest. So the value of this is -1. Similarly, when I say x is equal to 2, what is f of 2? Which is equal to 2. So now integer less than or equal to 2. What all integers that are less than or equal to 2? So we have 2 because it's included, it's an integer, right? So 2, 1, 0, -1, -2 and so on. So among these, which is greatest? 2. So the value of this is 2. So I hope this is clear. Now let's see the graph. So let's take 0, 1, 2, 3, 4. Here we have -1, -2, -3, -4. So 1, 2, 3, 4, 5. -1, -2, -3 and so on. So for x is equal to 1, your f of 1 is 1. So this is y. So for x is equal to 1, f of 1 is 1, right? So for x is equal to 1.5 also, value is 1. So for x is equal to 2, the value will be 2. So in between 1 to 2, for x values between 1 to 2, y value will be 1, agreed? So for values from 1 to 2, between 1 to 2, y value will be 1 itself. Similarly, for x is equal to 2 and for x is equal to 3, means in between 2 and 3, for the values of x in between 2 and 3, your y value will be 2. Say for example, if I take x is equal to 2.5, what is the value of f of x? F of 2.5. So f of 2.5 means integer less than or equal to 2.5. So it will be 2, 1, 0, -1. Among these, which is highest? 2. So for x is equal to 2.5 also we are getting 2. So for all the values ranging from 2 to 3, in between 2 to 3 x values, you will get y as 2. Similarly, for the value of -1, similarly for x is equal to -1, in between -1 to -2, x values from -1 to -2, your y value will be -1. So it's like this and so on. So I hope this is clear. Along with these functions, we also have trigonometric function and inverse trigonometric functions. We will see these two topics separately. So this is it in this video. See you soon. Till then, take care. Almighty bless.